Okay, guys, we're going to get started here. I'm Tyler Baker. This is Milo. And we've been working on a project with Kevin Hillman to do Upstream Kernel CI on a bunch of platforms. And so this session is really to just kind of go over the status of where we're at and then kind of get feedback and then review where we're going to go. So that's kind of the format of how this is going to work. Okay, so the agenda is going to be what is Upstream Kernel CI, status, and then we're going to do a demo, maybe a couple demos to kind of see how this works and see if there's a better way we could go about enabling this for developers, and then the next steps. So we really want you guys to be involved and have a discussion. If something doesn't look right or there's a use case we're missing, please bring it up and we'll have that discussion. That's kind of the format that I'm looking for. Okay, so what are the goals for this project? It's upstream focused. It's upstream trees. It's clean reporting, and when I mean clean reporting, not like obfuscated results everywhere, and it's hard to tell what's going on. We want the kernel team's feedback because in the end, they're the ones that are responsible for reviewing the results and fixing the bugs. So we want to make sure the reporting is what you expect. We don't want to have a whole lot of it, but we kind of want it to be minimal and concise and to the point. So the other thing we want it to be is fast. We want to get you guys feedback as soon as possible and without delay, at least for the first stage, boot tests. The deeper testing obviously will take longer, but the initial smoke tests with builds and boot tests, we want really quick feedback. We also want it to be scalable, and I'll talk about this a little bit more, how we're trying to do distributed labs using Lava, some not using Lava, but all basically contributing towards the end goal of reporting the status of the builds and the boots. So what we've been doing, there's Kevin, we've kind of been doing a pilot/beta of this, and I'm going to go through what we've done from the ground up and where we're at now, and give you guys a little demo here. Okay, so here's the system and diagram of what we have. So you guys are out here, you're developing the kernel source. We've chosen Jenkins, so ci.linaro.org to be our builder. And then we've got some bare metal builders. And this is really the system here that we're going to talk about today. So the builders trigger on every merge for different trees, and we'll go over that. And then the raw artifacts, so all the information about the builds, the kernel images, the DCBs, all that stuff gets published to a server where it's then hosted, and then the boot farms will pull from this repository and then boot test those binaries and then report back to that same spot. So you may have a server, the Cambridge lab or my home lab that uses Lava to boot test, and then you may have something like Kevin's lab or Mike Duquette's lab where it's not using Lava to boot test, but the interfaces to report back the results are the same. So that's kind of what we're going for, that we can get distributed board farms to all work together to work toward this main goal. And so the pieces that we don't really have in place right now are the emails and the reporting and the bisection. So those are going to be the next steps, and we want to talk about what makes sense there and kind of get a consensus on how we want to proceed. Is there any questions about this? Is this clear?
Just one question.
Let's use the mic.
Is this working? The Upstream Kernel CI system, is that a new thing you're building?
Yes.
Okay. Has it been built? Are you building it? What's the state of that?
We're going to get to that.
Okay,
so we're actually going to demo what we have and what we don't have.
Sorry, I could have missed this, but I see that the database could be directly queried. Like right now, I actually use Linaro image 2.0.
Image reports 2.0.
Image reports 2.0.
This is built out. The system's built outside of that. So
okay.
We're using Lava as a data publisher, right? To
Right.
get the data out of Lava, we're using Kevin's boot farm, PyBoot, to get the data from him and stick it in this database. Does that make sense?
Yeah. So I mean, like, I'm wondering if say for example, I just want to generate a view like I want. So I just need to pull out the data bits from the database that I specifically want.
There's a REST API, and Milo will go through that on the dashboard side of things. So if you want to be able to query the dashboard, there's access for that.
Okay.
Yep. This is the mic.
So maybe subsequent to Chris's question, to me it's not apparent what
you're going to build, what has been built, and what's in the process of being built.
Right. Okay, that's good because we're going to go through that in the demo, and I'll show you exactly the trees and the architectures we're building for, and then how to get your tree in to get this build and boot test going on. Okay, so I kind of went through this already. Build systems, publishing, hardware and boot systems. Now, we kind of just built this all from scratch. That's why it's taken a long time. It's we're part-time on this, and we decided, hey, we've got some different requirements that we can't immediately solve right now with some of the current infrastructure. So we more or less said, okay, we're going to go outside of this and really build something that we think the kernel developers are going to want. And then once we have something and we have agreement on it, then we're going to productionize it and pull it within Linaro infrastructure. So that's kind of the pilot beta program that we're doing. We're doing this because we can be fast and agile. We can, spin up a server if we need one and that kind of thing. So, and then we're going to show the dashboard and how all this reporting gets done. So, what's the status? I know I'm hearing this from two people already. So, automated upstream build validation on ARM SoC, mainline, Next. There's a few other LSK. There's a few other developer trees in there too. We're building them all the ARM def configs, the ARM64 and x86 def configs on every one of those trees. Now there are different branches that are being built on the LSK as well. So 310, 314, and we'll go through that. So after each build happens, we publish it to a server, and we'll show you that. And that way you can go through and look at the results if you just want to look at the web server. And then building interfaces. So we have like a JSON interface that when the build is done, the build produces this piece of JSON that the dashboard then will read and then put that into the database so that it can be viewed from a dashboard. Boot testing, Kevin's lab, he's got a whole bunch of boards in there, mostly ARM boards. I don't think you have any other. Yeah. Then in my lab, I've got ARM x86 and ARM64 boot tests happening, so multi-architecture booting on every single merge for all those trees. So we'll show you how that works. And then Milo's been really helpful in creating a results dashboard and really working close with Kevin and I to say, hey, it would be great if it could do this, and Milo's just like, yeah, I'll make that happen. So we're not front end or back end guys really. So you've been a big help. So what's not functional? Distributed testing aggregation. That is something that we are working on currently. Being able to have n number of board farms contributing to the bottom line. Ideally, what I'd like to see is infrastructure is inherently flaky, especially with these ARM boards. And that if we get a failure on a boot test, it would be nice to say, well, Kevin's board failed. My board booted fine with the same kernel, and maybe some other people's board booted fine. So that maybe can be marked as an infrastructure error because we have 6 other pieces of evidence that it actually did boot. So that's kind of what we're trying to do. And that way we can double check each other's work and kind of make sure it's more robust. And you guys as kernel developers can trust the results. That's really what we want. So visual charting and trends. I think this is going to be big. This is really what we need that we don't currently have, and this is kind of one of the next steps that I'm going to propose that we do. Email reports. Kevin's been sending them out on the mailing list, and it's using this system. So that email that you see on the Linux kernel build mailing list is generated from all of this. So build and boot by section. Now, we've mentioned this before. I don't know how feasible it is for us to do build by section since Intel's 0-day seems to be much, much faster than anything we've ever seen. So maybe we should just focus on boot by section because that's where we can add value. And we found a couple of things actually. It's been a bit of a manual process, but Arndale Octa stopped booting on mainline, or it's having intermittent issues. So it's something we reported in the mailing. So we've actually caught some issues with this already. And so it's looking like it's going to be feasible to do that. But ideally, we'd like that to be completely automated. And then testing. We're not testing other than just doing boot testing. And I know that's going to be a big thing, that we want to actually do testing. But I think what needs to happen is we need to do this in phases, right? We do boot tests really quickly, and we just know, did my change or other people's change break the existing platforms that we're already booting? Okay, if it didn't, then we move to developer testing, which maybe your tree has certain tests that you want to run on it, on all these different platforms. And then the next step, if those pass, is community testing, like LTP projects, PMQA, those kind of things that are deeper level that are going to require longer test runs, and then reporting of those results and being able to trend and visualize them. Fish. Let's use a microphone, Fish.
You said there are like various stages of tests.
That's what I'm proposing. Yeah.
Okay. I mean, like I was just going to suggest that we have test plans that we could just take and deploy.
Yep.
That's working out really great. So.
Yeah, absolutely. And that's kind of, we're still immature enough not to really be getting to that point yet. What we don't want to do is really just make this robust. And tell you what, just getting the builds to work reliably and figuring out how we could get decent time. So for all the ARM def configs on an upstream tree, I mean it's like 35 to 40 minutes, which is pretty acceptable for us right now. But with the Amazon EC2 instance that we had, it was like that wasn't feasible. It'd be a couple hours to do all of it. And so we kind of had to play around and figure out the build and publishing infrastructure just to make sure that was all reliable. So each step presents its own challenges, and we want to make sure we work through them properly and make sure it's going to be reliable, because there's nothing worse than having an infrastructure error when you're depending on it and you don't know whether it's the system or it's an actual error. And we want to completely avoid that. That's kind of where we're taking our time and making sure that this is going to work robustly. So,
Yeah.
So may I add one more thing in there, which is a set of reports about the status of our infrastructure.
Okay.
So being able to tell what the utilization of our infrastructure is, and being able to tell what different types of tests, test suites, how much time they take, so we can plan this better. So things like, if this is a critical test for release week, then we sort of have to bump up the priority or restrict. Yeah. So right now that is not visible. I'm sure you have all of that available to you somewhere, but we don't have access to any of that.
Yeah, no, and absolutely. So I think when we go, so the format, I think you missed it. What we're going to do is we're going to have a discussion. So we're going to kind of present the next steps, and then we want to get consensus on these kind of issues. So that was good. Did you write that down?
Yeah.
Okay.
You want to mention just, go ahead and mention just the guest host stuff. It's also on the functional side.
The guest host.
Guest booting.
Oh yeah. So that's the other thing that we have in Lava. We have VM groups. So I'm actually doing boot tests in KVM guests. So x86 KVMs and ARM KVMs. So on Arndale, and then we're hoping to enable some ARM64 platforms to do that as well. So being able to build the guest configurations for those kernels and also boot test them as virtual machines is kind of what we're going at too. And then being able to run tests inside of those is something that Lava enables today, but we kind of need to work out how that reporting works first before we start doing that. Are there any other comments, questions?
Is this current functional list, is that in the order of just starting to work on?
This? More or less, yeah. But we'll discuss it, the priorities, once we get, I want you guys to see the system working, because it's not just vaporware, this actually works. And then we can figure out what the next steps are, and we can prioritize them as a group, because I think everybody in this room here has a stake in this at some point, so we need to figure out where we need to go, and that's what we want you guys' feedback on. Okay. Who's got a kernel tree here? Raise your hand. Okay, we're going to do a little demo here. So, first things first, let me give you a little overview of what we were talking about. So here's the Jenkins build system that we've put together. Now, how's that? Okay. It's building trees right now. That's good. So here's the configuration matrix of the trees that we currently build today. So mainline master, next master, ARM SoC for next, ARM SoC to build. There's a developer tree there, the OMAP tree, a bunch of this different stable branches, and then you see that the architectures are the vertical columns there. So we do build them for the main architectures that we're really concerned with at this point.
So that's a daily build?
No, this is every time it changes, the tree changes.
Every time there's a new commit or a new branch push to any of those branches.
As you see right here, ARM64 LSK 314 is building right now. So if we go look at what this looks like. Oh no, it's stopped. It was just checking to see if there's. So here's all these jobs that we'll check for new changes, and then if there are new changes, then we'll kick off the build job, which is what I'll show you next. So this is the K-Builder job. This is where the work gets done. And what you can see here, if we take a look at this, it says what architecture it built here. There's ARM, ARM64, and if we take a look at this one here, and we can look at the parameters that were passed in, these are the parameters that are passed in from that trigger job. Now this is Jenkins foo. You guys might not understand this, but don't worry. You don't have to deal with this kind of stuff. This is just how the system works. So it passes in the architecture, the def config list, the tree to build, the branch to build, and then sometimes the tree can change quickly. So we also pass the commit ID so that we make sure we're actually, when it was triggered, we build what was triggered instead of pulling the latest and we might get something newer. So we had that problem. And then the tree name that you want to publish as. Now there's two little tick boxes here that say publish to Lava, which is published to our image server, and then there's submit to Lava, which submits the jobs that Lava can boot test and boot test them. So we'll kind of go through that.
Sorry, can you clarify that exactly?
Yeah.
Sure, you're just pushing the results off the build to Lava, but not actually running anything on Lava. That was the one option. What was the other option?
So there's publishing. So build all the kernels and def configs, and then publish them or don't.
Publish them to the database, essentially.
Yeah.
The database in your new system or the database in Lava?
No, database in the new system.
Got it.
Yeah. And then submitting to Lava basically instructs Lava to go find those binaries and boot test them and then report back. That's where we're going. Okay, so live demo time. Who's the first victim here? John.
Pick any random tree.
There's one. Is this just your timekeeping tree?
Yeah.
Maybe rebase. Let's see how bad that. So I'm going to just steal the URL here. Okay, here we go. So I just splat that in there, right? Which branch?
TGLX 317.
Let's take a look.
3 days ago, it was. Can't read all that. That's all it's possible to read there.
Yeah. Holy cow. Yeah, that is bad.
Go back to branches instead of tags.
Oh, there you go. Right here?
Yep. Sorry.
So we'll do some ARM configs, but let's say OMAP2 plus, is it OMAP2 plus def config. And then,
multi V7, that's a good one.
yeah. What is it, V7 like this?
Yep.
Okay, so I just gave a list. We say for the ARM architecture, here's your branch. Commit ID, we're just going to grab whatever's on the top. We don't really care. And then we can just say, so this tree name is going to be the name when it gets published on the images server. So let me show you what that's going to look like first. So here's our images server. You go to Kernel CI here. That name that I'm putting in there is going to show up here. So like I've got Tyler ARM64, and then there's the git describe. And if I go in here, there's the def config, and then we can also do fragments, so you can add different config options that you want to build for each def config as well. And so when you go in here, you'll see there's the image, and you can get the kernel config, and you can get the build log right here. But this is just the raw data. We have a dashboard that will display this in a more meaningful manner. But that's kind of the idea behind it. So we'll just do this, and then port GLX. How's that sound? So we want to publish it, the tree, and we want to submit it to Lava and boot test it. Is that pretty clear, what we're trying to do here? Okay, so we'll build it. Okay, so now it's spawned the different def configs on each builder, and it's gonna crank through them, and then it's gonna start publishing them. So once all of the def configs are done, assuming there's nothing broken, it's going to then submit a bunch of jobs to Lava. So we're gonna find out if anything's broken in this tree. So if we take a look, let's just see. So it might take some time. We'll keep moving on because it's going to clone the tree and have to build it all. So we'll come back and check on this one. So in the meantime, since we've kind of already gone through that, let's take a look at the status.arm cloud. Kevin's build reports are actually, our boot build reports are linking back to this already. So before we do that, actually, it would be a good idea. There's a little bit of Groovy foo here. Kevin's our Groovy expert now, and so he's added these nice links.
I got it from Fondy.
we steal a lot of things from Fondy, don't we?
Yeah.
Anyways, yeah, so we got some Groovy foo here. So if you want to go look directly at the results database and you're looking at Jenkins, you can just click this here and it'll take you to the exact build. And what this will show you here is that here are the broken def configs in the build. And then this kind of gives you an overview. So we built, 128 def configs built, 4 failed. Here's the git commit, here's the tree, here's the git describe, and here's the branch and tree name. So you're probably wondering, what does this look like if I go look at a build log? So let's take a look at the IMX6. So if you click on this, you'll get a little bit more info. So you can go look at the kernel config with a direct link. You can go look at the DTB directory if you want to grab a DTB out of the kernel. You can also click on the build log, and it's just condensed down. It's not the entire Jenkins build log. This is just the error. So we actually caught a merge conflict that went into ARM SOC the other day just by looking at this, saying, yeah, that's kind of interesting, and we started kind of bisecting it manually and said, oh, I think there was a merge conflict when it was pushed in here, and we got it fixed within like a day. So it seems to be working pretty well as far as the data that it describes. Now, is there any comments on this part? Does this look reasonable to everybody?
So the status.armcloud.us is just basically another system server somewhere, right? Where we're basically publishing from ci.linaro.org.
Yep. This is the front end server that displays the results that are essentially the raw results that are kept in here.
I mean, I understand from ci.linaro.org it's running Jenkins. What is running on this one? Do you know?
So everything from Jenkins is synced back to this server, but it's actually hosted at Tyler's. The backend is a Tornado web server, and the front end is a Flask application.
Okay.
So what you see here is a simple Python application with a lot of JavaScript.
Okay.
So where this?
Yeah, custom stuff.
Okay. So what we've kind of tried to do here, now this is when you go to status.armcloud.us, we want to kind of at a glance what's the status of the upstream trees, and that's kind of what we're going after. So here you can see the last 25 failed builds, and what this describes is the tree, the branch, the git describe, and then this is the number of def configs that have failed. So if we go look at next, if we click on this guy here, you can see that 1 def config failed, and again, the information is presented to you exactly why it failed.
How do you decide which lines you snip out and which one you do those?
It's in Kevin's build scripts.
What, the build logs?
Yeah.
It's just the standard error to make output.
Okay.
That's it.
It tells you how long it took to build and things like that. And then you can also look at all the successful ones if you really care. But what I find is nice is if you click on the tree here, then you can kind of delta the builds a little bit. So you can see here on 9.12 at this commit here, every def config built properly. But the next couple of commits, there's now been a regression introduced, at least as far as building a certain def config, which will be picked up here. And that's kind of where I want to go for the next steps, is be able to trend that so that we can get an email notification when something like that happens and says, hey, this is the new build error that just happened. It didn't happen here, but it's now happening here. And then eventually even give you the git bisection points. Here's the start, here's the end. And then maybe we automate that, or just that's information for the developer to go and do that at their desk to figure out where the error is. And so you can see it's probably the same build error.
Just to interrupt here.
Go ahead.
So I see the failures over here, and it's hard for me to understand. Maybe I'm just taking at the wrong use case, but when I check in something, when I push something, it has compiled, right? So how many of these failures like this do you get, and for what reason?
Lots. Okay, Kevin,
Because most people have that attitude, it builds for me, it's good. This is why we need this system, because there's so many other, especially for upstream maintainers that are, you can push something into a tree that builds for you and boots for you, but it might actually break other people's platforms or in unexpected ways, and so that's why we need this. And this is a really common problem upstream, is unintentionally breaking other people's stuff.
Yeah.
So that, and for some of the core areas that we're starting to work on, we only test on ARM. We don't have the hardware to test on as many platforms as possible. So Kevin's lab or something else, we have a lot of hardware, x86, other stuff. That's another reason.
So we're also building, so for ARM there's like 130 def configs, so we build all those, but we also have the ability to do a base def config and say turn on a PM feature or turn on LPAE or Big Indian or stuff like that, and a lot of people aren't doing that, so we're only doing a few variants, but as we build this out we can start doing all sorts of different config fragments.
Yeah, so if we look at the
We can do ran config. In fact, we do ran config, except ran config is to the point where it always generates lots of errors. So it's not useful because we don't have the stuff in place to see what's new errors, what's old errors. So ran config is basically just noise.
Yeah.
But we're getting to the. It's getting better. Arnd is actually working on that pretty actively. So, but yeah, we can do ran config. It's just turned off.
And so that's what Kevin was talking about here. Here's the multi-V7 depth configs with different fragments enabled, and we were able to build and boot test those separately.
So who owns this thing, and how? I mean, if there are use cases where we feel like that view is not what we need, what
right here?
Okay, and so what's the procedure for that? Is that cards and regular stuff,
No,
or
just come talk to us?
Okay.
Is this an official? Is this still a Skunkworks project? Or is this
Skunkworks pilot, but what we want to do is okay. Go ahead, Actually.
So I guess the question I had, maybe this is for the later discussion, is
this has been a Skunkworks project for like a year now. So what do we do? At what point does this become an official Linaro thing? So it's not Kevin's, that's not your basement anymore, your backyard, and it's actually like an official Linaro project that we're working on. Like, what's the next step for that?
Well, I personally would like to work on this as much as I can, but due to my duties with the Lava software project, and Lava's just a tiny piece of this problem, right? So I think we just need to get agreement that this is a priority for us, and that we can actually push this and say we want this as a engineering organization, and then we get the time allocated and we get the resources allocated. Because as Kevin knows, I mean, running a board farm, and Matt and Dave both know that it's a lot of work to do that, and we want to be able to scale this up. Use the Cambridge lab, use our own labs. So it does take kind of like personal time to get this stuff working. But I personally would like to see this once we feel ready to go and say we want to do this production thing. We hit the button and go. But before we do that, I think it's very important, like what Christopher was saying. How do we make feature enhancements? I want this tweaked a certain way that we get that kind of fleshed out, at least at the basic boot test level, and maybe some bisection before we say go, because everybody can agree this information that's being presented is useful to us, and that the system is reliable, and it's providing us good information before we say, make this a project, get it done. That way we all agree on the requirements, and we understand the expectations of what's going to happen when we finish it.
Yeah, I just want to follow up on the Pat comment. So basically, I've seen the thing, and we've been working on the Kernel CI since a long time. Yeah. And to be honest, the only new thing coming up in the last 6 months was the dashboard.
Yep.
And it's the easy part. So I think doing a pilot is good, but we really need to work on the staffing and make it not a spare time project, because looking at the missing thing, like more than boot testing, it's really the difficult part.
Yeah.
And if it's not 6 months spare time.
Exactly. Well, and that's why I think yeah, that's why. Yeah, exactly. It's why it's on the list. So from your point of view too, I mean, you have a lot to do. We have a lot to do. So I think we need dedicated resources on this to really drive this to something that's usable.
So another aspect of this is that this is the first I'm seeing of this specific thing. When talking about our needs from the virtualization group, so far I've been told that, well, I should look at QA reports, which is what's solving this problem, where this looks much more promising for what I'm needing, right? So I think it's pretty critical at this point, if we start investing resources, that you guys, whoever owns this, goes out and talks to every single person in Linaro that uses this, and talks to them and figure out what is the missing pieces for you for this to be really, really good for you, instead of just going down one road, right? Because, at some point, if you invest a lot of resources going down one direction, you can't change that later.
Yeah. And so we've had Milos in the meetings to make sure that we're syncing up with what he's doing with QA reports, because I think what Milos is doing, he's kind of ahead of us as far as the reporting aspect of things and being able to display the test results and the builds and things like that. So we are working together with him, but yeah, I mean, I do agree. We need to merge this and make this something that everyone can use very shortly.
Not everyone, but yeah.
And for me, because I'm on the kernel team, I've been kind of feeling like I can represent the needs of the kernel team, and that's why we've gotten up to here. So if there's things like for you should come talk to me, because for stuff that you need kernel-wise, we can definitely add that. But I've been kind of doing it just from the kernel, upstream kernel perspective. I have a pretty good idea what everybody needs because it's what I need. But yeah, for new, I mean, clearly it's not everybody, so.
And this is a participant-based system where you need to say, this is my use case, and you need to
Oh, I'm all for that.
Yeah.
But I mean, one thing that I want to make sure, for example, is that because I work co-maintaining this with people outside Linaro, and I want to make sure that I can use this for saying, well, for our tree that we co-maintain, go here, right? And you can log that in. They can use that. It's something we can easily share, and it's easily understandable with the community who are not part of Linaro and don't know Jenkins lingo and stuff like that, right?
So my primary audience for what I built has never been Linaro. It's been upstream maintainers, and that's my email goes primarily to people that are maintainers of all these ARM platforms that are in the community. So that's always been my focus. So this is making it useful to Linaro is part of the goal, but it hasn't been the primary goal, at least from upstream kernel perspective.
I mean, one direction that I'm thinking of is like, it's almost like a very useful service, right? So if you actually map like, okay, so I'm like, say for example, an MMC domain maintainer in my company or whatever, and I'm upstreaming some of the MMC patches or whatever. And as my manager, right, you know, we care about certain pieces of hardware, certain configurations, and then we basically care about certain test plans. So every single time I push a patch, I build tests for a selected number of diff configs and a selected number of hardware, and then a selected test plans, right, beyond that. Now that would be of super value because, you know, depending upon that particular company's needs, then they could basically say, hey, this is like a build test as a service, really, right? Basically where people can, you know, you have a big kernel upstreaming team, your charter is to make sure that this particular hardware keeps working, it doesn't break the builds for the upstream stuff, so you can basically say, all right, these diff configs, this hardware, these test plans, the results, right? That would be pretty amazing, I would think.
Ideally, what I see this happening is that you can subscribe your tree for your branch for all the def configs or a certain subset, and then you'd be able to describe this system, the test that you want it to run, right? I mean, so that use case could be handled there. It would be, here's the information and here's the test that I want you to run after, you know, these things build. So something like that is, I think, what we're going after. We're not anywhere close to that yet. So we need to keep focused on, let's make this reliable, let's get the value out of it now, and then move. I mean, we need to be thinking about these, but we need everybody's involvement in this room to really drive this and say, no, we need testing now, and here's how we need to do it, and this is what we need to do because you guys are the experts here. And I think this is kind of why, you know, up to this point, we really haven't had this view of things, right? Because we kind of, you know, this team is working on it. We all need to own this, right? And we all need to be involved in it. So I really think that your involvement and your use cases and your feedback is critical to this and to help drive us in the right direction.
And the Achilles heel is going to be that test plans, right? I mean, you can support building configurations, but if you don't have those tests, right, that people can choose from, the test plans that people can choose from, that would be, it's kind of a chicken versus egg problem, right? If they have that, they're not going to use it. And you don't have that because you don't have the resources.
I'm going to reply to this one. I think it's a bit different of a goal that we have on the Upstream Kernel CI. It's more generic Kernel CI that we already cover. Your use case, this one, the one that you described, is already covered by the generic CI.
If I can comment on Vish's request, I guess it's a different goal here. So testing, like broader testing in this with this approach shouldn't happen. Well, at this stage at least. So it's very far from now if it's going to happen. And if it's going to happen, we have to change our approach a lot because what we are doing now is very much different from what's happening here.
Okay, so I want to go through this dashboard because we don't have a whole lot of time left here. So if you click on the Jobs tab here, just kind of walk you through this. Here are the jobs that have ran, dates, and their status. So that kind of gives you an overview of, you know, what's been building and so forth and so on there, and you can filter the results down. Now you can click on the Builds tab, which basically just gives you an overview of all the builds and their status. So there's a fair bit of noise here, but you can see the def configs in the tree, and then, you know, this thing says, hey, there's a build failed here, and so kind of gives you an overview there. But we're trying to condense this down a little bit more. But what's interesting?
Has been made project based, so you don't see both sides.
You can filter directly from the URL. So if you put like a normal query in the URL, it will filter for what you need. But if you want a specific view, it's not completed yet. But if you click on a kernel, for example, you will see the view for that kernel or the view for that tree. It's not all for everything, but it's possible to do.
Okay. And so what I really like about this is I've never been able to go somewhere. So let's say I buy a Panda board right now. Right? I go, does it boot an upstream kernel? Or I'm having problems booting an upstream kernel. Where do I go? I got to go to the mailing list, and I'm the newbie on the mailing list saying, oh, I forgot, I need to shift my load address over here. I'm sorry, guys, sorry for the noise. You can come here and you can see exactly how we booted it, right? With the load addresses, what binaries we use so that it's reproducible. That somebody that's trying to figure out if their platform works upstream can simply go here and reference it. I think there's a lot of value in that for the community aspect, not so much our direct engineering value, but that's always a question I had. In fact, I was on the mailing list with the QB truck trying to figure out how to get it booted with the mainline kernel because everybody said it worked, and it just turned out to be some little bit of U-boot config that relocated the initRD. And all of that's captured here, so I think there's value in that. So let's keep going on the slides before we get derailed here completely. This is good though.
Show from the boots view if you just care about one board, you just type your board into that search box and you see an entire history for that board, all the boot reports for that board.
So let's see, Panda. So here's all the variants of the Panda.
So you see the different trees, the different def configs.
And then this status is here completed, and so you can kind of scroll down through here and see it. So that's kind of the idea too, is why we want to aggregate all these results so that if there's a failure that you can look and say, no, this was boot tested in 6 farms and there were 6 failures. This is most likely a kernel issue, rather than one failure, which may indicate an infrastructure error.
So I guess what's the current catch rate? Like, I mean, as far as when issues crop up, how often are you actually seeing them? How quickly are they getting, sent to the actual maintainers? Like, what are the to some extent, our success isn't the green boxes; it's turning the red boxes.
Exactly.
So I can answer. At least for my part of this, which has been the boot testing and boot reporting, we're to the point now that there's rarely failures. So when there are failures, people will hear from me within that day or within a couple days, and the turnaround has actually been quite good and especially because now, like, I send out these email boot reports, but now I can link to the actual boot logs and this status and stuff. So we're actually I'm getting really quick turnaround to the point where there's 1 or 2 failures a day, and if there's a lot, then I have a busy morning and I send out a few emails, but it's actually pretty rare. It's getting rare, so that's what we want. Once you get to this point where they're mostly passing and only rare failures, then the turnaround is actually quite good.
And so this is just an example boot log that you might see. So Kevin's got it nicely broken down into different sections here. And he basically says, here's when the automation framework's taking control, and here's what he's sending to U-boot, and then the entire kernel boots. And then any warnings that might have been caught, you highlight stack traces and kernel oopses and stuff too.
So then this is what I send immediately to somebody when something fails, and then they can see pretty quickly what happened.
We'll get to you, I think, 5 minutes.
Yeah, I have 2 questions. So first one is, how many builds do we have right now for the performance scalability of interface?
For what we show, we only show the last 5 days of building, because it's a lot of data actually. So just 15 days of data is compressed. Is storing 10 megabytes of JSON. Actually, the backend and the frontend speaks JSON. It's only JSON. So in total, I think the other day we had like 19,000 builds for boot reports. I think it's around 20,000 from when we started, at least boot reports. Probably something more for the build parts. You can query from the API for whatever you want. The front end is only showing the last 5 days of results.
So what's the retention policy?
We're keeping everything for now. The database is not so big, actually. The data stored in the database doesn't take up too much space. It takes time to show it to you, but I think we can keep it for quite a long time.
And I'm keeping all the builds, because I've got a 40 terabyte cluster that I'm trying to play with the redundancy and the failover, so I want a big data set that I can play around with at some point. So I'm not getting rid of any of these builds. And if you go into, you can actually see there's at the bottom like the raw boot reports here of like what Kevin sends out on the mailing list are also are synced here. So if you're curious and you don't want to deal with the dashboard, all the raw data is available to you if you want to pick through it, or you want to reproduce a problem. All the binaries are produced. Git commits if you want to build it from source. So try to keep those options open.
Okay, and the second question is about the notification capabilities, because it was an issue on Lava side and build side. So we can get notification from Jenkins, we can get notification from Lava, and do we have any notification capabilities?
So that was the next part of the slide here, email reporting. So what we're going to talk about is we want the dashboard itself to be the notification, because it's going to be able to tell if there was a regression, because it knows when the last time something built properly, all the dev configs built, and that knows when a new failure. So that's kind of why we want to get the dashboard trends, so that we can easily detect these issues and highlight them some way. Ideally, it would send out a notification to the mailing list saying, at this build here, you know, on this date, everything passed, and then this build here, these dev configs failed. Here, you can go to the dashboard to find out more information. Ideally, we can send you start and endpoints for bisection to do it at your desk. So I think that's the next piece, and that's really where we want to go, is trending, reporting, and then distributed aggregation of the results. So
one thing for the reporting and the notification was an idea to have an RSS feed for, I don't know, like all the builds for one tree or whatever, so you just go to the status and just subscribe to the RSS feed. The backend already has some sort of notification system, but it's disabled because we never actually get to it. It actually can send directly emails from when he start parsing the data, and if there's a fail, automatically he can send an email out.
Let's see, your stuff's still building, unfortunately. But you want to talk about the backend? And because Vish was asking about the API real quick.
Yeah, so for the backend, if you want to query the backend, there's the API .mcloud.us, and it's the same API we're using to populate the front end. So it speaks the same thing. You need a token. Right now it's end provision, but we don't have anything to automatically provision tokens. But you have a couple of examples and how the API works. It just speaks JSON, so all the data you get out is JSON. If it needs be, we can probably implement different formats to export the data, spreadsheet, CDS, whatever.
So before we continue on here, I want to.
Probably smile. Yeah.
Go ahead.
Just interested by the backend part. How that's the use case: new dev config available, new device, new board in the lab. How do you map that?
Right now, yeah, go ahead.
It's kind of automatic. So if you have, but I mean, from the build, it's actually the build that gives us the data. So the build needs to provide us the correct data. Whatever the builds provide us, it's showing up here. So if you have like a new board and the board has a new name or whatever you want to call it, it's up in the database. It will be stored in the database.
And how do you know the device type for Lava?
So yeah. So what we're trying to do is standardize on names, because if we want to do this distributed boot aggregation, right, we need to standardize on names. So I've got a mapping in my scripts that goes through and basically can point it at the ARM Cloud, the raw data. It'll go through and detect. So it's basically a big data structure of mappings, and there's things in there like, hey, this doesn't support LPAE, so don't boot test the LPAE def config because it won't work, right? So we can blacklist and whitelist def configs in there. So that's actually what I was going to show you.
It's stated simply, it's basically a mapping from device trees to device types. So device tree names to Lava device types.
So this is my boot farm here. I've got 52 boards. Not all of them boot upstream, but you can see kind of what the Lava jobs look like now. Kevin and I have worked pretty closely to optimize getting these boot times down. So if you see on the far right column there, you know, there's some that are 4 minutes depending on the platform, like the x86 machine. That's a bare metal machine that we're bootstrapping with the latest mainline kernel, so it takes a little bit longer. But all the ARM platforms are usually about 1.5 minutes, some are under a minute. So every single tree is being boot tested in my lab right now, and I've got a little bit of reporting set up. Now my goal, what I'm working on, is to get the same format that Kevin's reporting in, pulling that out of Lava and getting that up there, and then we can share the scripts with everybody else. They're already out there. I think Mark and Kevin, you've used them before to generate the stuff, so we're going to kind of extend those a little bit. And then I've got, here's basic mainline ARM, multi-V7 platforms, and then this is just Lava's visualization that I was using just to kind of track and see the status of the boots. But this data will be then exported to the kernel dashboard along with anybody else that has a Torg farm to boot with.
I know I've asked this for a while, but I was kind of curious how far maybe we are away from being able to run this on all the trees on git.linaro.org. For at least build testing. I think so. Right, but you do it once.
There's your boot test right now, just by the way. So they just showed it to my server, so...
Did I boot?
We're going to find out.
Okay.
But if we go back here, you can see that, there it is, I just saw it. Here it is. See that? That's your tree that just built. And if you go in here, there's the git describe, and then there's the def configs that we asked it to build. And so then the boot test will ideally be booted in my farm in the Cambridge lab where we don't have like certain hardware like Juno available to us, and then the Cambridge lab would then report, my lab would report, Kevin's lab would report, and then anybody else that's got, maybe Olaf could get on it too as well.
So,
sorry.
Git.linaro.org. You're doing all the trees with anybody?
So I can answer.
Okay.
Yeah.
The short answer, there's no reason we can't do it now, and I actually started adding some git.linaro.org trees. The problem is they fail a lot, and so it becomes a matter of we need better reporting and more useful reporting. Otherwise, it's just a lot of noise. Like so, so one of the trees I'm building out of there is the LSK tree, and then I also added the Linux Linaro tree. But it turns out the Linux Linaro tree, because it pulls in some Android patches, actually breaks for 80% of the def configs because of this, I don't know, that IPv6, the classic one that nobody seems to want to fix. So it's just, I mean, it's dumb stuff like that, but nobody cares, and so I reported a couple times, nobody cares, so I just turn them off. So, but once we get better reporting, I think it'll be easier to add more trees in and to see, okay, we have this threshold of failures. It's more like what's new failures and what's old failures rather than just a pile of errors. But that's the only, well, that's to me the primary obstacle. The other one is just we only have 5 build slaves right now. So if we add all those trees, we're definitely going to hit the capacity. And so, but we can provision more slaves if this is a priority. The nice thing about this, we can just pay for a bunch more build slaves and it'll scale very quickly from the build side.
For me, if I were to get a manual email every time, a tree didn't fail.
Okay, so I think we're out of time, but so this effort focused primarily in a pilot on upstream kernel CI, a lot of that. At 12 o'clock, Milos is going to be talking about QA reports for Linaro Kernel CI efforts. And then today at 5:10, we will be doing kind of a brainstorming session, and then later in the week we'll be doing a planning session of the output of it.
So if you're interested, please join us and get your input in.
So let us know 5 p.m. today for the brainstorm.
Thanks, everyone.